Good morning, girls and guys. Hope y'all have had a great start to your day whenever you're watching this. I'm prepping this really far in advance. Today is actually the day we had an hour delay, so I am refreshed and ready to go this morning. I hope you are too. So today we are starting our first learning target of our next unit. Our next unit is dealing a lot with quadratics and graphing and factoring and things. It's a really fun unit. Factoring is one of my favorite things in math. It's at the very end of the unit, but we'll get there. It'll be super fun. So today our learning target is I can graph quadratic equations that are given in Vertex form. So you should be watching this video after you already did the activity that was listed above this in Delta Math. It should have said something about discovery. You should have done that first. So if you haven't done that, please go back and do that prior. But if you have, so you're ready to go ahead and do notes. So hopefully with that discovery activity, you were able to kind of notice a few things about depending on what number you changed or what spot the number was in, it kind of changed the graph. And that's really what we're focusing on today. So we can title this quadratic Vertex form graphing. So I'm using a new document camera. So if we ever have any technical issues, it's because I don't know really how to work it yet. So we'll play it by ear, or if you like the other one better, let me know. Okay, so Vertex form, the form for that is, so Vertex form is going to be y equals a times x minus h squared plus k. So this should look very familiar. We talked about this formula in the beginning of the year when we were doing absolute value graphing. So even if you don't remember that, that's okay. We'll go ahead and we'll go back over the basics. So your vertex point is given by h comma k. The k value moves your graph up and down. So if it's a positive, if your k value is positive, it moves it up. If your k value is negative, it moves it down. Your h value moves the graph left and right. I forgot the word moves, but y'all know what I'm talking about. This one's kind of counterintuitive. So if your h value is positive, it moves the graph to the left. If your h graph value is negative, it moves it to the right. And then our a value, that determines like the stretch of the graph. So that's like if it's really wide or really narrow. It also determines whether the graph opens up or down. So if your a value is positive, you open up. If it's negative, you open down. So those are the need to knows of this function. So this should look kind of familiar. We talked about it briefly when we were doing absolute value stuff, but we're really going to be using this formula here. So make sure you kind of memorize this. I'd color code this if I was you, just to make sure that we all are on the same page. So quadratics are essentially anything with like 3 terms and it's squared. You've seen these all the time. You just probably haven't heard that term quadratic before. But we're really dealing with this formula. So if I gave you y equals x squared, and I asked you to graph it, I think all of you could be like, okay, well, if I was sketching this, I would have a U shape that opens upwards. And you all know this. You all have seen this graph plenty of times before. So x squared, that's what we call a parent function. Oh, I ran out of room. That's what we call a parent function. So all the stuff we're working with is essentially just an extension of the parent function x squared, So for example, if we wanted to graph y equals negative x plus 3 squared minus 5. So this is just going to be a different variation of our parent function. So using our knowledge from our h, our k, and our a, and also a couple other things, we're going to be able to graph this. So the first thing you're going to want to do is come up with your vertex. So your vertex is h comma k. So I don't know if you remember me talking about this when we did absolute value, but the tricky part of this is making sure your h value matches your formula. So we rewrote this when we were doing the absolute value stuff, but if you can do it in your head, that's fine too. We want our equation to be x minus h. Here we have x plus h. So if this is a plus sign here, that means that our h value had to have been negative. So you can kind of think about it of your h value is always the opposite of whatever you see. So if you see a positive 3, your h is a negative 3. If you see a negative 3, your h is a positive 3. And then your k value, it's going to stay the same. So your vertex of the graph is negative 3, negative 5. So we'll draw a little graph over here. And let's see. So we'll have that to get started. So I know my vertex, but I don't really know any other point on this graph. So when we don't know, we're going to make an XY table. So we're going to have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So we have negative 3, negative 5. Oops, I did not make my graph big enough, but that's okay. So we know it's going to be negative. We know our A value, oh, you can't see that. Our A value is negative, so it's going to be opening downwards. So if we were asked to sketch this graph, there's a difference between sketching and actually graphing. So a sketch doesn't actually have to be like too accurate as long as you have the right shape, like the right vertex and things. So if we were to sketch this, we would just kind of go like this, and we'd go like this, and we'd call that good. But if we wanted to know some points on the graph, remember when we did absolute value, I always said to put your vertex in the middle, and then I would do negative 4, negative 5, negative 2, and negative 1. So I think you all know how to do this by now, but just as a refresher, if I have an x value and I have an equation, I can plug in my x value, I can simplify, and I can solve for y. So if I plug in negative 5, that's going to give me y equals negative 5 plus 3 squared minus 5, which is going to give me negative 9. And I'm going to do the same thing for 4, negative 2, and 1. If I plug in negative 4, I'm going to get negative 6. Plug in negative 2, I'm going to get negative 6. Plug in negative 1, I'm going to get negative 9. So what do we notice about these y values? They repeat. So if you remember back to absolute value, we talked about that axis of symmetry. Remember, your axis of symmetry is always going to be the x value of your vertex. So x equals negative 3 is my axis of symmetry. So we can draw a little line right through here. Oh, well, I missed that point, but you know what I mean. This is going to be x equals 3. So that means if the point over here, so for instance, negative 2, we're at negative 6. So we'll say that's right here. One spot to the left of that, we're also going to be at negative 6 for our negative 4. Let's see. Negative 5, we're at 9, would be off the paper. But once you have that vertex, and if you have one point over here, you're going to know a point over here. If you have a point over here, you're going to know a point over here, so on and so forth. So the axis of symmetry is very, very helpful. So I'm going to abbreviate that AOS for axis of symmetry. So remember, the axis of symmetry means that if I had this graph and I folded it in half like this, it would lay on top of itself very, very evenly. So essentially, all we did was we used this formula. So I like the XY table better. I like doing it that way. But if you know that your vertex, or if you don't even know your vertex, but we had our parent function, we know that this is going to go to the left 3, 1, 2, 3. It's going to go down 5 because our k is minus 5, and it's going to open downwards. So this helps us sketch it. This helps us get it very, very accurate. Both are very, very useful. And this will help you double check yourself to make sure you're doing it correctly. Also, something to talk about would be your max and minimum. So your maximum on this graph would be x equals -3, because this is the tallest point. And then your minimum, we don't really have one because it's going on and on forever into this negative direction. So we don't have a minimum. Our domain, so domain, remember, is the restrictions on our x values. So we don't really have any restrictions on our x values because, as you can see here, we plugged in -5, -4, like there's no dividing by 0 or anything. So your domain value is all real numbers, and that's how it is with 99% of quadratics, so that's helpful. And then lastly, your range. Your range is the restrictions on your y values. So the only restriction on our y value is that it can't be any higher than -5, wherever, see, this is our y value right here at -5. All of our other y values are going to be below this. So our range is that y has to be less than or equal to -5. So these are very, very helpful to help you identify the parts of the graph. You all should be kind of familiar with these things. But your Delta Math assignment might not necessarily ask you about domain and range, but your test could. So please make sure you are aware of what these words mean and things like that. All right, let's check my notes here. Okay. So, all right. So then if we had y equals x minus 3 squared. Remember that if we don't have a k value, we don't want to change anything about the problem. So our k value is just going to be +0. So that means that my vertex, it's always the opposite for your h. So -3 becomes +3 and my k stays the same. 3, 0. I know that since my a value is a 1, my graph is going to open up. So I can make my little sketch here. My vertex is 3, 0, 1, 2, 3, 4, 1, 2, 3, 4. Or I know that if I didn't have my vertex, if I just wanted to use this to graph it, I know that I'm not going up or down any because my k value is 0. So I'm going to be at the origin. And then -3, that's going to move me to the right 3. So 1, 2, 3. And it's the same as my vertex. And I'm going to be opening upwards, but I want to actually graph this graph or draw it. I want it to have precise points. So I know that my axis of symmetry is x equals 3, because it's always that x coordinate of your vertex. So I can go ahead and I can draw this here. And I can make my xy table. So 3, we'll put 3 in the middle of our table. We'll do 2, 1, 4, and 5. So if I plug in 1, did I do 1? Oh yeah. So if I plug in 1, 1 minus 3 is -2. -2 squared is 4. 2 minus 3 is -1. -1 squared is 1. 4 minus 3 is 1 squared, which is going to be 1. So remember our pattern. I have 0, 1, 1. So this one is going to be 4 as well. So I'm going to graph this. I'm going to have 1, 4. I'm going to have 2. Oh, I graphed that at 3, didn't I? 1, 4. Then I'm going to have 2, 1, 3, 0. I'm going to have 4, 1. And then I'm going to have 5, 4. And I'm going to connect my graph, making sure it's curved. Obviously, they're not going to be perfect, but they're as close as we can get them. Then, since this one is opening upwards, I'm going to have a minimum at x equals 3. That's my lowest x value. I'm not going to have a maximum because it goes on forever. Your domain is all real numbers. And then your range, your only limitation for your y values is that your y has to be greater than or equal to 0. Okay, so I want you to take a second to try and sketch. Try and sketch y equals negative x plus 2 squared minus 3. So I'm going to pause for a second, let you actually try to do that. Okay, so the first thing you're going to do if you just want to sketch is you're going to note your a value. So my a tells me this is going to be opening down. And then I'm going to need my vertex. So remember, it's the opposite for your h, so it's going to be negative 2, and it's the same for your k. So I'm going to make a quick little sketch right here. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm going to go to negative 2, negative 3. And then my graph is going to be opening downwards, and it's always going to be that U shape. So your axis of symmetry would be right here. Your maximum would be x equals 3. All right, so now we're going to try it a little bit differently. So instead of sketching it, I want us to practice describing it in words. So if I have y equals negative x minus 4 squared plus 5, I want to know how is this transformed compared to the parent function. So remember we talked about the parent function was just the regular x squared. So we want to know how is this different than x squared. Well, our a value tells us that it's going to be opening downwards, or another way that that's mathematically said is that it's flipped over the x-axis. This is our a value. For our h value, I have minus 4, so that's going to be the opposite of what we think, and it's going to be to the right 4. And then we have our k value. It's a plus 5, so it's going to be up 5. All right, you take a second and see what you can determine for x plus 1 squared minus 6. So I don't have an a value on this one, so nothing's being flipped, so I really don't have to worry about this one. For my h value, I have a plus 1, so that's going to move it to the left 1 unit. My k value is minus 6, so that's going to move it down 6 units. Okay, so there's a couple different forms that this stuff is going to be given to us in. Vertex form is probably the most user-friendly form, so it's really a good idea that we get a good grasp on this. So I do want to show you your assignment for today. So I have a new camera, so give me a second if I can. Oh, well, that was easy. Look at that. Oh, well, that's fancy. Okay, so this is what you should have done first before you watch this video. We're going to be plotting points and graphing functions. So actually, now that I think about it, you'll be doing this in class with me, but just as an introduction, we will be going to problem This doesn't do what I wanted to. You'll be given problems just like this one. You'll be asked to plot 5 points. So you plot your vertex, you'd make your XY table. And then when you hit done plotting points, it's going to give you that pencil to let you draw the graph like we've done in previous assignments before. We did it last unit with radicals. And then this equation or this section is going to be, well, we're not dealing with absolute value. There we go. It's going to give us a graph, and we're going to have to use our knowledge of graphs in order to be able to pick which one of these goes with this graph. So for instance, this one, it's going to be opening upwards. So we're going to want a positive A value. So it's not going to be C and it's not going to be B. It looks like we went down to -4. So our K value is going to be -4. So this one is the only option. And we got it right. So practicing with graphing, practicing from looking at graphing or graphs, and making sure that we're taking note of all those features of graphs like max and min, and range, and axis of symmetry, and all that jazz. So if you have any questions, please reach out. If you have any missing work, please make sure you're working on that. But I look forward to seeing you guys whenever I see you. Hope you have a great day. Now can I figure out how to turn this off? Oh.